So for this last part of the screencast for week, 13 going into 14. So this worksheet took a while to understand because flux was kind of a novel concept to me, I guess, which basically refers to sort of the density of field lines. Um, and so as flux changes, then there will be current induced in a wire. My question is that, so my thinking goes like this. As the magnet is moved in towards the ring, there is a stronger magnetic field that the wire experiences in the left-hand direction. That was confusing me a little bit because it seems like the magnetic field lines go from north to south pole, but directly sort of in front of the magnet, they're going to the left. So they'd go straight and then wrap around. So anyway, magnetic field to the left, and that is strengthening. Now, according to Lenz's law, there is an urge, a tendency to counteract that increasing magnetic field. And so then there's a magnetic field induced in the wire that opposes that strengthening magnetic field to the left. And so that would mean that the current would flow through the wire such that it would have a magnetic field induced in it that is to the right. And so if we use our right-hand rule to see which way the current should move in order to produce a magnetic field to the right, you'd see that the current moves in a certain direction from the back side of the loop, wrapping around to the front side. Okay, so that also suggests that then, so that's the current. And so that resulted in A having a higher potential, more positive charge than B. But it's interesting because across the resistor, it seems that it would go from high potential to low potential, so A to B, the current would, but yet the current is not continuing around in the same direction around the loop. Oh, yes, it is. But it's going from a lower potential B to a higher potential A as it goes around the loop. So my question is the loop acting like a battery where it's actually pushing charge in a place it doesn't want to go? Kind of like the teacher notes suggested was occurring for the rod that's moving in the magnetic field. It acts almost like a battery. So it continually replenishes sort of positive charge at A so that it maintains a higher potential than at B. And so that's my current thinking, I guess. And I am going to try to, get that thinking straightened out as the night goes on. And so some of these are difficult because it's you're thinking about three-dimensional sort of axes, but yet you're only seeing it on two-dimensional paper. So my colleague suggested, well, we use a hula hoop and a meter stick as the magnet moving in and out of the hula hoop, which represents the current of the wire loop. So that seemed like a great suggestion. And simulations, again, would probably also help to allow students to visualize this rather than just drawing it or projecting it from, a two-dimensional surface like a chalkboard.